Okay, so now I'm going to show you some of the practice problems from, let's see if I can figure this out, from the end of your notes. Okay. Sorry, can you imagine that there's people banging on the outside of my window? Kids. All right. So the first problem says a sports car accelerates constantly from rest to 95 meters per second in 6.2 seconds. What is its acceleration? Every time I do a kinematics problem, the first thing I do is I write v naught v a dt, because these are always the variables we'll be looking for. You need three numbers to be able to solve. In this case, when the car says, or when the problem says that the car starts from rest, then v initial is 0. It gets up to a final velocity of 95 meters per second, and we're told that it does that in 6.2 seconds. So your first job is to find the equation that doesn't have t in it. So we choose v equals v naught plus at because we are not told to find d and we don't know anything about d, so we choose the equation without d in it. Once you've chosen the right equation, it's a matter of just plugging in and solving. So we do algebra, substitute in 95 for v, 0 for v naught, 6.2 for t, and do algebra. Acceleration is always measured in meters per second squared. So that's kinematics. You write down your variables, you fill in the information, choose the right equation, and solve. Let's look at the next problem. A ball is dropped from a rest of 20 meters from rest. A ball is dropped from a height of 20 meters from rest. What is the velocity after it has fallen 20 meters? How long will it take to hit the ground? When we initially read this problem, we see v initial is 0 and then it falls 20 meters, but we're not given specifically an acceleration. But this ball is falling because gravity pulls on it, which means it's going to accelerate at 9.8 meters per second squared. Now we have three numbers we can solve. So here I'm going to pick the equation that doesn't have time in it. I substitute in, I do algebra, I solve. So that ball is going to be moving about 19.8 meters per second before it hits the ground. You can also then go back and choose a different equation, v equals v naught plus at, substitute in, and you find that it takes 2.02 seconds to hit the ground. The order you solve that in, whether you do this first or this first, doesn't matter. And once you have four numbers, you can choose any of the five equations to find the fifth variable. One more. So here we have two things going on. We have a car that's sitting at a traffic light, and then we have a truck that goes kind of zooming past at a constant speed of 20 meters per second. Now, the question is, how far beyond its starting point does the car overtake the truck? So you need all five variables for the car because it's accelerating. You only need three variables for the truck because of the key word in the problem, constant velocity. Now, I asked this to my class earlier. I said, what do you have to know about the car for it to catch the truck? And someone said, well, they have to have the same velocity. But the truth of the matter is, if you're trying to catch someone who's passed you, you'll never catch them if you run at a constant velocity. So just a tip, if you're trying to tackle someone, if they're in front of you and you're trying to catch them, you have to go faster than they are currently going. All right. The trick to this problem is realizing that your distance that they both travel is the same and the time they both travel is the same. So we don't have numbers, but we could let this be the variable d, the variable t, the variable d, and the variable t, and we'd have simultaneous equations. All right, so this is as far as I got in my other classes, so I'm going to stop here. You should work on your WebAssign now or your vector map lab, and if you have questions, send me an email. Good luck.